This video is going to review geometric series that are infinite and talk a little bit about two different kinds. The ones that converge and the other ones that diverge. When they diverge, they basically are growing and getting bigger and bigger. Example here. This is 2 plus 4 plus 8 plus 16. And it's probably pretty obvious to you that the common ratio in this geometric series is 2, because it's doubling each time. So 2 times 2 is 4, 4 times 2 is 8, and so on. In this particular case, the common ratio, or the absolute value of this common ratio is 2, which is greater than 1. And in those cases, there's going to be no limit. And we're not going to be able to find a sum of that because it just basically is going to go on to infinity. These shapes, just kind of give you a little bit of an idea. If you look at these shapes and think about this being the first term, this being the second term, this doubling, and think kind of like the area. Oops, that's probably not even big enough. The fourth term would be even bigger. It needs to be about double. I'm just kind of ballparking it here. Oh, and this one, the next one I can't even make. But they're going to get bigger and bigger and bigger, and you can see the sum of these numbers is going to be infinity. The other example is a geometric series that converges, and in this case, we go from 8 to 4 to 2 to 1 to 1/2 to 1/4. And the common ratio is 1/2, or you can also think of it as 0.5. And that's a number that's absolute value is less than 1. And think about it this way. If this is the first term, and that's the second term, which is half as big, then I have another term, then I have another term, and each term, or each the size is half of the smaller one. It's littler and littler, so little I can't even draw it. Now it will go on to infinity, but it gets so teeny that it's going to be closer and closer to a sum. And it's getting, basically each additional term is getting closer and closer to 0 and getting smaller and smaller and smaller. And we can actually calculate a number that is the sum that it is approaching, all right, which we'll never reach, but it's approaching. So let's move to the next slide. This is a formula for the sum of an infinite geometric series, but this has to be one where the common ratio is, the absolute value of the common ratio is less than 1, all right? And that's the only time that we can actually calculate it. This is the formula. It's going to be A1, the first term, over 1 minus R, R being the common ratio. Let's work through at least one example and possibly the second, depending on whether my video runs out. In this case, my common ratio here is 0.5. And what I'm going to do is go ahead and take my first term and use this formula. My first term is 1. So it's 1 over 1 minus 0.5. Alright, so that's going to equal 1 over 0.5. So 1 over 1/2 is actually the same as 2. You can kind of do it this way if you want to think about it this way. 1 over 1/2, or 1 over 0.5 is like 1 over 1/2, or 1 divided by 1 over 2. And if you want to think about it as a fraction, we could make that multiplying by 2 over 1, which would also give me 2. In math, you shouldn't be writing over your work, but with different colors, I think you can see my general idea. In example number 2, we have to find the common ratio first. So I'm going to go ahead and use algebra for that one. I want to know how I go from 3 to negative 3 over 2. So I'm going to use an R for my unknown common ratio. 3 times this unknown common ratio is going to equal negative 3 over 2. Now I want to isolate R to find out what that number is. I'm going to divide both sides by 3. And this side, I think I'll just do it this way. Divide by 3. And I'm going to change that to negative 3 over 2 times 1 over 3. And you can see if these two cancel out, I'm going to end up with negative 1/2 as my common ratio. R equals negative 1/2. So let's try this, see how far I can get before my slide ends. My